Welcome to the first SAICE Civil Talk for 2024. We're very excited to have you with us tonight, and thank you so much for affording us 90 minutes of your Thursday afternoon. My name is Ntabeleng Lenzwane, and I am the head of marketing and PR at SAICE National Office. Before we continue, I see Kay has their hand up. Before we begin, Kay, I'm just going, oh, okay, Kay's hand is down. So we're going to continue. Thanks once again for joining us this evening. We're honored to host you for this thought-provoking and very important technical discussion. We've titled it PC Column to Beam Connections. So whether you're a seasoned professional or you are starting out in the world of structural engineering, you're in the right place at the right time doing the right thing, and we believe you are in for a treat today. We'll be diving into one of the most crucial aspects this evening of structural integrity, and that is how to effectively connect columns to beams. SAICE is a learner society, and as a learner society, we stand on the foundation of the mandate of advancing professional development, and the speakers that are here with us tonight will ensure that that knowledge is shared and that a conversation also is sparked, which will hopefully yield much value to you in your daily work, in your various spheres of influence. So in a short while, I'll be handing over to our learned colleagues who will be exploring the key principles and some of the best practices that entail civil as we know it. Winston, Visser, who's the project manager at Peikko, and Vesa Miettinen, who's the product manager at Peikko, are here to support in exploring the various opportunities within design and to also assist us in combating the common challenges that are faced by engineering professionals. Our colleagues are also here to provide expert insights on how to overcome those challenges. So throughout the webinar, we really encourage you to keep engaged and actively participate in the conversation. You can do that by posting questions in the chat box throughout the course of the presentation. And at the end of the formalities, we'll then set aside a few minutes for Q&A, where we will deal with the questions that will be in the chat. And we'll also give you an opportunity to raise your hand. You do have that functionality. And once you raise your hand, we'll then enable your audio so that you are able to ask your questions verbally. So once again, enjoy the session with us this afternoon. Keep engaged. It is CPD accredited. So please do stay for the duration of the session in order for you to receive your certificate after this session. And without further ado, I'm going to now share the presentation and then invite Winston and Vesa to turn their cameras and audio on. And we're going to kickstart the session tonight. Thank you. Vesa and Winston, if you can hear me, you can just turn your videos on. I see you both. And I'm going to share the presentation and we're going to kick off. Thank you. Vesa, over to you.
All right, thank you for the introduction, Ntabeleng. So my name is Vesa Miettinen, as you heard. I'm working as a product manager in Peikko Group, product manager for bolted connections. Shortly about me, I have been in Peikko for 15 years. I started in Peikko, Finland, as a customer engineer. Then I moved to Middle East. I was there for more than 10 years, and now last year I moved back to Finland and joined Peikko Group here in Finland again. So I think that's shortly about me. If Winston, you will say a few words about you, and then we can continue with the presentation.
Thank you, Vesa. Tabaleng, thank you for the introduction. Good evening, everyone. My name is Winston Visser. I've been in the construction sector since 2009 after my graduation from the University of Johannesburg. I'm with Peikko South Africa now for 5 years, acting as Peikko South Africa's project engineer. We are also today, thank you for the opportunity for me and Vesa. We are looking forward to share our ways of construction with you, and I hope you enjoy it. Thank you very much.
Okay, so let me first tell a few words about Peikko as a company. I think there might be people who haven't heard about our company. So it's headquartered in Lahti, Finland, established in 1965. So we are more than 50 years old company now. We have certified manufacturing in 12 countries as of last year. Our aim is to make our items what we produce in our own factories, and we have more than 30 countries covered by the sales teams, globally over 2,000 employees, and last year's turnover was 262 million euros. Actually, I haven't done the calculation what it is in South African rands, but maybe you can do the math there. And here you can see the map where we are covered. So it started from Europe, and then now we are spreading all around, and we are a global company. Okay, and business categories, we have 2 categories, which is delta beam and delta beam frame. These are slim. This delta beam is a slim floor composite concrete steel composite beam, and we are also providing concrete steel composite frames for the columns, so full frame system there. And the other business category where we focus today is the connections. So we have precast connections, cast in situ connections. All are in the same business category here. All right, today we are focusing on the rigid connections, rigid beam to column connections. But first, I will say a few words about the pinned connections. So of course, we also provide pinned connections for beams if that's what you're looking for in your project. So on the right side, you see a few examples. We have the PC beam corbel, the yellow PCS corbel, and PC beam shoe, which can be embedded in the precast beam. On the other hand, if you have, for example, steel beam, you can connect it with Trelda connectors to the concrete structure. So these are few options what you can do pinned connections with our items. But yeah, the main focus today is for the rigid connections. Here you can see the places where we can add those rigid connections. So it's column to foundation, and of course column to column where you have the column splicing. You can add the same items there, and today's focus is in the column to beam connections. So we will see some samples how to do column to beam rigid connections, what to take into account, and some design principles for those. Okay, starting from the anchoring couplers. So of course, one thing why would you don't want to use anchor bolts in beam connection, because you would have some threaded bars sticking out from the concrete surface. So this is not a way to go when you want to rest your beam on top of the corbel. So you would like to have couplers embedded in your column, So it allows the beam to slide in and go to on top of the corbel, and afterwards you will only add those threaded parts inside the anchoring couplers. And of course, you would like to. The aim is to fix it properly, like you see here. For example, you can fix it properly in the reinforcement. And typically, these couplers you bolt through the formwork of your precast column, so it will stay fit during the casting. We have sizes covering from M16 to M52. A lot of different types of anchors. If you're looking for headed anchors, these are available, as well as bent anchors, what you see here on the left side of the picture. And then, of course, straight anchors or double-sided anchors. If you have beam connection on both sides, you can use those as well, or combination of all of those. Then beam shoes. So shoes, as you see here, are welded already in the factory. So these are everything we talk about here today are mechanical connections. So you don't have any side weldings on site. So we provide only the mechanical connections here. So it's fast and easy on the site. So of course, shoes are also covering the same sizes from 16 to 52. And we always, if you use a certain size of anchoring coupler, you match it with the same size of the shoe. And those shoes are color coded, as you can see here. This is a gray color coded shoe, and it has those welded anchoring bars, which you overlap or lap splice with your main reinforcement in your beam to transfer the forces from the connection to the beam. And then in the bottom plate, you have that oversized hole, which allows you the tolerance to be placed, the threaded part to be placed there. We also provide these steel recess formers. You see on the bottom right, you have these red and green samples there. So these are the ones you place inside the shoe recess. After casting, you can remove it, and it will leave you this nice recess, what you see here on the beam. So these are also available for making it easier on the precast factory. All right, then few words about connection design. So firstly, if you think about the moment design, you have some forces what you need to transfer from the beam to the column through these connection items. So here you can see the shoes. So you place the shoes, in this case, in the top and bottom. You lap splice it with your beam reinforcement. Then the forces will go through this mechanical anchor, which is bolted through this bottom plate hole all the way to the column. So we transfer then anchor it to the column with either the head or bend shape of anchor. So tension forces are transferred with these connection items. But what comes from moment, the compression force from moment, typically we don't have a nut in the joint, a nut and washer in the joint, so we rely on the compression with the grout and the concrete of the column. So this is a little bit different. In our column connection, we also have a nut typically on the joint, because the joint thickness is thicker and it's easier to place it in the column joint. So there we can also transfer the compression forces with the anchors, but in beam connection, the most common case is that we transfer those forces, only tension forces with these items, not the compression force. Of course, the shear, as we will hear later, will also transfer with these connection items. All right. Shear design, the major shear, the vertical shear will be taken by the corbel. Usually it's either concrete corbel. Next slide we'll see a couple of different options for the corbels. But can you go back to the slide, please? Yes. So yeah, we'll take it with the corbel, whether it's underneath or hidden inside the beam section if that's possible. This is of course because these vertical forces are usually quite high. It doesn't make sense to transfer those forces with the connection items because those connection items would get very heavy in that case. So it's common practice to transfer it with the corbel. And now if you go to the next slide, please. Here you see few typical cases what we can use for. So in this photo you can see at least concrete corbel there, extended corbel where you can also see this dapped end. So this is from one pipe rack project which we have done in the past. So one thing, of course, with this kind of extended corbel is that you can shift your connection point a little bit further away from the surface of the column where typically the highest forces are, so you can also optimize the connection items by that way. And then steel corbels are also possible, of course, if you use steel corbels to transfer the vertical shear forces. So those are the most commonly used options we have come up. All right, shear design. So vertical shear, as we spoke, transferred with the corbel, but horizontal shear force then we transfer with the connection items. So yeah, as I mentioned, typically there's no nut in the joint, so we cannot clamp the bottom plate of the column shoe or beam shoe between those nuts and washers to transfer those forces. So we have to take into account the lever arm in our calculations when we do the shear calculations for the horizontal shear. It has been done in some cases, like you can see here on the top of the corbels. There are those additional shear dowels. These can be, of course, added there if you want to enhance the horizontal shear for shear transfer. So in the bottom where you see the beam, there are those holes where the dapped end is, and the corresponding dowels are on the corbel side. So those will go through those holes, and then they will crowd it in, and this will transfer also the horizontal shear forces in that case. Torsion design, then we will calculate these connectors to take into account the torsion. And here on the top, you can see the formulation for if you have 4 connection items. It's of course much simpler, and we use this polar moment of inertia to transfer this torsion. Actually, the torsion will be changed to additional shear force for the items, and then convert to the shear capacity of the items. And we have this new tool which I will mention later on. We have this Peikko Designer bolted connection. It's an online based tool, and that also calculates this torsion. So you can just copy paste your static results from your static software to this our software that run the connection analysis. So it will take it into account there. So you don't have to have 4 connection items, or you can have, for example, 12, what you see here on the right side. So it's not limited there. Then few words about the corrosion protection. So of course, the most typical corrosion protection is just concrete cover. So in here on the right side, you see that the shoes are offset inside the section, and then you would have some concrete cover on top of it. So this will take care of the corrosion protection, and this is the most commonly used method we have done in our projects. Another option, of course, if you go to the next slide, please, is hot dip galvanizing. That's another way to go if you are not able to reach the sufficient concrete cover. You could galvanize those items and enhance the corrosion protection on that way. Last option is the most difficult one, I would say, epoxy galvanizing, because shoes are possible to be epoxy coated, but those threaded items are not. So only the shoes can be done with epoxy coating, but then you'd still need to have hot dip galvanized threaded items together with this. So these are more or less the options. But I would say this concrete cover, this is the most affordable and easiest way to handle this corrosion protection. Then modified items. We are also supplying modified items depending on your project needs. So it's not. We understand it's not only the standard items you can always fit in your sections or in your cases. So here on the right side you see some combined shoes. For example, we can combine 2 shoes on a one bottom plate, or it can be even more than 2. It can be multiple shoes on one plate, and another type of special anchor on the right side. So we are doing this, and if you have needs in your projects, please contact your local support, and we can propose you this kind of modified items for them. Supplementary reinforcement for the elements. So of course, if you have a precast element, you have to always have some supplementary reinforcement, and in the first place you would need to follow the technical manual instructions for each shoe type. We are giving the additional reinforcement instructions, although there can be some special cases, like you can see on the right side. If you have some dabbed ends, for example, it's not, those instructions from technical manual are not directly applicable necessarily in your project. So in that case, please contact the local support, for example, Winston, who is here, and he can help you out with additional or supplementary reinforcement in your special cases. Okay, so installation, I will try to explain it, the words, that how it goes on the building site. So you have a precast beam, which you have delivered on the building site. So before lifting, the easiest way, before lifting the beam up, you put those threaded bars, which will later on go to these anchoring couplers. You will put it in the recesses ready already before lifting it up from the ground. Then you lift the beam up, place it on the corbels, as you see here. Then typically you have one extra nut what you use to screw in you tighten those 2 nuts against each other and screw it into the coupler. Then you can take away the other nut, so that the threaded bars are tightly fit inside the couplers. And then you just do the tightening of the nuts for the connection. And then finally you fill in the joint with the non-shrink grout and also the recess boxes there. And maybe one hint that sometimes it's good to place some shim plates between the joint, so that there will be no displacements when you start tightening those nuts. There might be, of course, that the column might lean onto the beam a little bit if those forces are quite high, depending on your item sizes, connection item sizes. So sometimes it's good practice to put some shim plates in the joint before starting the torquing. Two different tightening methods what we have recommended in our projects. So we have, of course, case where you could have a torque wrench on site, and then you would just follow the torque values. For example, on the right side we are showing here for some of the items the minimum torque values you need to reach on the site. Then it will be quite straightforward if you have this, but this is not always the case, and some of the sites you can rely on this nut rotation method. So first you snug tight the nuts for all those connection items, and then you mark the reference line, as you see here on the bottom right. So you mark the reference line where is your starting point, and then as per the instructions, for example, 1/3 of the turn, 120 degrees angle, you you tighten after snug tightening, you tighten at 120 degrees, and then your connection is tight. So these two options are the most commonly used what we have seen. Okay, and where Peikko can add value, of course, fast construction. As I mentioned, it's all mechanical connections, so there is no welding needed on the building site. And big benefit is also maybe if you can show the previous slide briefly. So you don't need to actually build any platforms. You can operate directly from the man lift. Sorry, can you show one more back? Installation. Yeah, there you go. So sometimes, of course, depending on your method, but you need to build some platforms, and this is a huge time consumption, and then move those platforms from one place to another. So with this method, you can just operate from the man lift. It's very easy and simple. Saves a lot of time on the building site. Sorry, could you go back to that next one? Here we go. Yeah. And of course, we have a local customer engineering support. So whatever problems you face, you can always contact our local support, engineering support, and we have experience. We have done these projects before. We have the know-how already. We have some references. We have approvals. So this is of course where we add value in Peikko. Next, please. Okay, so calculation tools. I assume most of you are engineers doing the design. So we have had for a longer time already this Peikko Designer, which is a desktop tool. So it's still available. You can go to that address on below and download it and start using it. It's free. But then now we are developing this new calculation tool, which is already published. And you can use the same user account if you have already established your desktop user account. Same account works there as well. So this is a newer tool where we'll put all the focus in the future. So you can have a look on both of those addresses and try it out. And last slide from my side is this is a screenshot from the new tool. So it's a very simple to use, easy to use tool. So it has more features, and we are constantly adding more features in this online tool. So we have added already a lot of features, and now in the coming months we'll add more features such as supplementary reinforcement calculations and long bolt calculations and national annexes. If you're using a Euro codes, the national annexes for some of the countries are being added there. So all the time updating the new tool. Old tool we are not putting much effort anymore. So we are focusing only this new tool. And for example, torsal calculation is something unique, and the 3D capacity graph, what you see on the right side, these are the new features in this tool which are not available in the old one. But that's all from my side for now. So I'll hand it over to Winston, who is our local guy in South Africa, and will tell you more about the references there.
Thank you, Vesa. I will be sharing a few pilot projects that we've done in South Africa and Africa, and just go through the process of using our mechanical connections, what benefit it has towards the client and the construction team on site. This is a project that was the existing factory in Roodepoort. The project was called Stand 28 Technikon Johannesburg. So what the client requested from us was to lift basically the whole existing structure and add a second floor. So at the back of the structure, we lifted the roof and then constructed 1,000 squares within in the factory. The remarkable aspect on the structure was at the bottom you can see there at the grey area, that was an existing retaining wall. We've got a basement level at the bottom of natural ground level. So what made it very remarkable is the way we fixed the concrete columns that you can see on the front of the building. So we opened the existing floor section that was supported on the retaining wall, and then we created a small stub that tied into the retaining wall, and we placed our anchor bolts into those stubs, where then afterwards we came in and construct the precast columns and beams that was manufactured off-site. From the first column arriving on site to the stage where we were constructing the new steel roof section, we constructed this section in 5 days. That was the construction time, which the client also appreciated due to the fact that they've got a lot of deliveries and stock that needs to go out from the client side to his customers. This was a very interesting project we did in Cape Town. The project was called Rappy Road. It was a residential house that we constructed. With this project, we worked with architect team. They were based in the United States. So what made this house remarkable is the customer wanted this house to be self-sustainable. We precasted all the elements on this project. So you will see basically we've created V-shaped beams on the column, supporting these V-shaped roof beams. So wherever you walk in this room in the house and you look up to the roof, you will see these precast V-shapes, and then the light coming through, and then you can basically see the whole Table Mountain looking through this precast roof. So we constructed the columns in precast. We also had to do insulation in these columns. It was big 13.5 meter triangular columns. We precasted the beams with Peikko anchor bolts and column shoes. This building consisted of 3 floors, and the construction period took 5 months. This is a project that we've done in Kenya called SAICE Factory. Here we also did the factory. It consisted of 2 floors. The area for the factory was 10,000 squares. So all the detailing happened inside, and we feeded the client with the precast drawings. The client undertook on this project building his own factory, so he used his own staff to construct the precast members. We had so you will see the precast beams, and then what Vesa discussed earlier on, we used our composite delta beam on this project. The nice thing of using these delta beams is we're making the beam the depth of the floor, so you don't have downstand or upstand beams in these areas. And then we used hollow core slabs for the flooring. The construction on these 2 stories, consisting 5,000 squares each, the construction took 4 months. This is a project that we did in Randburg, in Johannesburg. This was also a residential development. This structure consisted of 7 floors. We had 2 levels parking, and then we had this massive atrium, as you can see on the inside. We used our anchor bolts on this project, coming from foundation to first level of parking, with our column shoes. We tied the beams to the columns is we created sleeves through the beams, and then the anchor bolts protruding at the top of the column going through the sleeves that got grouted up, and then the next floor, it was ready to receive the next floor's column. This structure was 10,800 squares. We constructed this building in 4 months. You won't believe, with 2 people. We had 74 columns per floor on the structure. 2 people constructed it in 3 days. Then we did the lining and leveling. Then started with the grouting process while we were placing the next floor beams. There were 54 precast beams per floor that we constructed in a day and a half. And then the guys doing the flooring came in afterwards, constructing 2,300 squares over a 4-day period. So the nice thing with using the Peikko connection on your projects is, for instance, on this project, we were turning 2,300 squares every second week. This is a warehouse we've done in Johannesburg. The interesting thing about this project was, you can see the roof at the top. So the client wanted to add a second floor in his existing building to create office space. So what also makes this remarkable, we had to work in confined spaces, constructing our precast columns and beams with our mechanical connections. When we constructed the structure and we reached the second floor stage, the client realized that the roof area, where you can see the new hollow core sections, is going to be wasted space. So we battled to basically, then we had to lift the roof, because then the client saw the benefits. Instead of adding a floor, he added basically 2 floors of office space. So we constructed the precast facade on the inside. We placed the second floor hollow core slab and then lifted the roof. So currently the client is consisting of a 3-floor office block. This construction in a confined space with headroom height problems with the crane, we constructed this in 4 days. This was a fantastic project for Peikko South Africa. We did it with Stefanuti Stocks being the main contractor. The client was Ivan Platz, and we had to, the client came to us and said to us they need to construct this plenum for this mine shaft. But the problem is doing a conventional method of construction. We had these walls were 10 meters high, and the incline on the site was at a 25-degree slope. So if they had to construct it conventionally, as soon as you moved up with the construction of the shaft, we would have had to leave all the backpropping in position when we started backfilling this. So we came with a proposal on this project by basically using RC with precast. We call it a hybrid construction method. So we did cavity walls. So we manufactured the precast planks off-site, also consisting with our column shoes and anchor bolts. And then we basically constructed the two planks on top of one another, creating a cavity. Then we placed our main reinforcement within this cavity, and we did ferrules through the precast planks, and then started filling these cavity walls gradually with concrete until we reached the top level. And then we also constructed the top section with concrete planks. You can see on the picture on the middle section, we had bars sticking out that basically tied into the precast plank on top, and then we covered it with a structural concrete topping, just tying the frame together. The benefits in doing this project in the way we did, we saved the client 8 months by doing this precast planks with the concrete infill, which saved the client at the end of the project 160 million rand. This is a project we're currently busy with in Cape Town, called the watering building. On this project, we started after builders break this year on the 16th of January, and we started with the construction of these precast elements. We had 26 columns on this project, ranging from 7.5 meters to 12.4 meters. 80% of the columns on this project was 12.4 meters. Like Vesa showed on his slides earlier, here we had to go with a moment connection between the beam and the column due to the seismic requirements in Cape Town. So we took 3 months to construct all the precast elements on this project, and then we're going now week 4, finishing off the project. That's consisting of 26 columns, 126 beams. So also using the copra connection, you can see on this column closer to you, with those caps, we've casted the copras into the column, placing the beam with a column shoe that's cast into the ends of the beam and getting fixed to the column. We also had an expansion joint in the middle. So the nice thing as well with this is everything was manufactured off drawing. We supplied the main contractor with steel templates to get the setting out on site correct, fitting the anchor bolts already in the steel templates, casting the anchor bolts into the foundations, and these same templates gets used at the precast plant to make sure that we align the column shoe with the anchor bolt. The steel roof okay, just before I go to steel roof, you will also see we've created this big corbels in the column, going basically perpendicular. Those columns, we're going to need, the customer wants an overhead crane that will be fixed to those corbels, and an overhead crane to move in this warehouse. We also use the copra connection, working close with the project engineers, getting the setting out and the fixing details of the steel roof on the structure. So we already made allowance casting the copra at the top of the column. So the steel contractor already also manufactured the steel roof off-site. So when they bring the elements to site, he's just going to fix his trusses directly to our copra connection. So there's no need to go and drill 13 meters up in the air to make allowance to fix your end plates of your roof structures. And that, we're coming to the end. I hope you enjoyed it. And I was saying at Peikko, a faster, safer, and more sustainable way to design and build. Thank you.
Thank you. If you have any questions, I think we're happy to take questions and try to answer those.
Thank you so much, Vesa and Winston. I think that was really informative. Thank you for those insights and that information. Also for the case studies and the references as well. I think they were very useful. Like you said, Vesa, we're going to open now for time for Q&A. So if there's any questions that you have, this is your opportunity to ask those questions. Vesa and Winston, I think, and Wade, I'll give you a chance now. But I think while we're waiting for the hands, if you can raise your hands if you'd like us to enable your audio, and we'll do that. And I see there's also been a bit of interaction in the chat. Maybe you want to take those, and then we'll go into the hands. Yeah.
Yes, okay, let me check the questions.
Okay, I think while you're checking, can I give Moiloi opportunity to ask a question?
For sure, yes.
Okay, let me just allow your mic. There we go. Please unmute and ask your question. Good evening.
Hello, everybody. How are you doing?
Good evening. Fine, thank you.
I'm good, thanks. My question is on it's on the moment connections. So I see that this system is very efficient in terms of cost savings and construction, right? Speed of construction. The question I have is, are the moment connections, the moment capacities in connections between beams and columns, are they still retained? Are they still retained in terms of, as compared to the cast integral of the column and the beam on site, compared to connections around that joint? My question is, are the moment capacities in those joints, are they still retained, mean to say?
No, I'm not sure if I got the question right, but if maybe I'll try to answer and then tell me if I didn't understand the question right. But yeah, the basic idea of this moment connection is that it's more or less the same principle as you have with the reinforced concrete in monolithic casting situ. So you take the tension with the reinforcement, which is in this case the mechanical connectors, and then most of the compression will go through the grout to the concrete below the grout. So the same principle basically works there. Of course, apart from the casting situ, we have corbel here, which will take the shear force. So this is different. Typically in casting situ, you will not create a separate corbel for the shear forces. So that's maybe the biggest difference there between the casting situ and this precast connection here.
Okay, thank you very much, sir. I really appreciate it.
Thank you.
Thank you. Shall we go to the chat?
Yeah, sure. I
And-
found here a question from Nico. How a precast beam attached to a cast in situ column, specifically talking about accuracy of casting in the anchors. How do you ensure that anchors are cast in accurately? So if it's a cast in situ column, then you would of course bolt those. You would have to have a opening for those anchors in the side of your casting mold. So that mold, the fitting in that should be pretty tight. So when you have, for example, M30 thread, you will make 31 or 32 millimeter hole and push it through. So it cannot move much there. And of course, on the other inside the concrete, you tie it into the reinforcement there in the column section side. So that could be that will secure it, so it will not move during the casting, and it will be in the right place. And of course, we have some tolerance in our column or beam shoes. So there is a tolerance because it's an oversized hole. It doesn't have to have perfect fitting, but of course, it's a must to use to bolt it through the formwork, or in case of column connection, to use template when you cast the anchor bolt through.
I see also a question here from Andrew Miller. Does Peikko subcontract the casting of the precast beams and columns to third-party yard? So Andrew, what we do is so we are getting involved with the professional team on the project, and if there's allowance to do alternative design on the structure, going with a precast solution, then we can always advise precasters in Johannesburg or in your area that we've used before and that knows how our mechanical connections work. But you also, if you've got the capability and your site allows it, you as contractor can even do the casting yourself on site. And then we guide you through the whole process from the beginning to the end, and make sure that the mechanical connections is casted correctly in the elements, and we see the whole process from the start to the finish. We go through the whole thing with you and making it a success.
I can take the follow-up question also from Nico, that what codes and standards is the design software capable of using? So the older tool, the desktop tool, has Euro codes and ACI included in it, and the newer tool currently has only Euro codes, but ACI calculation is also in plans to be added there. So currently we are not including the South African standards there. Of course, in the future, if there is a demand, that can be discussed. But yeah, there's no plans as of now to include this South African standards there.
There's another question here from unknown user. So Mr. Unknown User asking, my quick question is, how do you ensure joints are sealed? Also, is this applicable only to building or concrete water retaining structures as well? So to answer the question, Peikko connections, all the connections gets grouted up on site with a non-shrink grout. We rely on that compression that the grout gives us between the elements. And yes, we can definitely assist you in concrete water retaining structures by making use of our connections.
I see there's 2 hands in the chat, so I'm going to unmute. I'm going to allow Nico's mic. If you can unmute and ask your question, Nico.
Thank you. Good afternoon, Vesa and Winston. I just have a quick thank you for answering my question. Thank you for answering my question earlier. I just have a quick a question regarding the software specifically, because you have got moment connections which will encompass a tension and a compression force. Now, with that tension force, you need to design, for example, your column to it's able to withstand that tension from the anchor. So, with your software, does that include does that include the codes from ETAG where supplementary reinforcement is used, or is that purely based on the concrete elements themselves? Because as you know, if you have anchors in concrete with pull out, I mean, there's loads of different factors you have to check for cone breakouts and pull outs, etc. like that. Is that all taken into account in the software?
Yes, it's taken in the old. As I mentioned, the newer tool, the supplementary reinforcement, is being added in the coming months. But that is already incorporated in the desktop tool, so it takes it into account as exactly you mentioned. The ETAG calculation is there, and the new tool is already checking the concrete failure modes. Cone failure, splitting failure, blowout failure, all these are checked already, but supplementary reinforcements is being added in the coming months.
Oh, I see. And there's calculation sheets and all of that is available if you want to put it into reports, etc. like that.
Yeah, you can have a printout from the software. Yes.
Okay. Thank you. That's my question.
Pleasure.
Thanks very much, Nico. Before we continue in the chat, I'd like to greet Daniel. Welcome. Going to allow your mic. Please unmute, Daniel. Good evening.
Hi guys, Tabaleng, thank you very much. I'm not having question. I'm happy. I just want to add something regarding the finishes to our product. So the boys they mentioned that the products come as standard black. It can be hot dip galvanized. There's a different local treatment available, which we're in R&D mode, which is called thermal fusion coating, which is even more superior to the hot dip galvanized. We can bring the product as stainless steel, particularly for water retaining structure. And we can even take it further to alkaline resistant, depending on the condition, the soil condition, and everything on site. So there's a variety. One of the largest water retaining structure in Spain is done with Peikko connections. We've got projects done in Netherlands also for dams using our connections, and we've got for the last 2-3 years a lot of inquiries for reservoirs in South Africa, anything from 5 to 30 million liter capacity structures that we get asked to quote and provide solution, particularly as you know, in a structure inside you've got columns and beams. So that's we can assist you with the frame before even to start considering the outer walls and looking for some alternative solution. That's all what I wanted to say. Thank you.
Okay,
Thank
I
you so
see here.
much.
Sorry, Tabaleng. I see here in the chats. Just another question. Please, can you discuss how hollow core floor panels were tied to the PCB for seismic loading transfer? So what we did with the project in Cape Town is on the precast beams. When we casted them, we left exposed laces sticking out on top of the beam. When the hollow core was placed, so cores gets opened in the slab for 1.2 meters. These bars then gets bent down in a staggering formation into the hollow core, and then a structural topping gets placed on this hollow core planks, tying the plank to the beam.
Okay. Thanks, Winston. I think for everyone's benefit, Daniel is the MD of Peikko. So just to say thank you for joining us and for those comments. Let's continue. John, I see your hand is up. Let me just allow your mic. You can unmute and ask your question, please. Thank you. Is John there? John, please unmute and ask your question.
I was talking to myself. So Winston, you were obviously talking about composite action there with the rebar tying into the echo slab with the topping, eh?
Yes, John. How are you?
Fine, and yourself? Good.
No, also fine, thank you.
I've just got a question for Daniel. With the reservoirs, how do you seal the joints? Do you provide an in situ like a gap with a water bar, or how do you deal with that?
All right, John. Let's start first from the columns. The columns. You know that most of the time they're going to have an anchorage depth specify, which means that the actual connection in relation to the finished surface of the reservoir is going to be anchored. I don't know how much. I'm throwing a number of 300-400 below. So you're going to have a full concrete incast, in the connection around the column. So you're going to have your concrete casing, and that's protecting the connection. The connection can come already to site, means the anchor bolts and the shoe, as we say, in the different surface treatment, HDG as a entry level or something else. So that's how we're dealing with the column itself. Column to beam inside, which is on a high level, just underneath the lid. It's in a similar fashion, and then the walls are still on R&D, because again the walls will be anchored below the surface of your tank, and and then from there on to take the segments of the wall.
But the vertical joints in the walls, I'm
the vertical
specifically.
The vertical joints of the wall, it's a all different ball game. That can be a monolithic connection, vertical ties with loops, and then you can either bandage the joint.
Bandaging
is a one option.
Yeah.
Either you can have interlocking mechanism between the two walls with vertical weather bar, which that's a better joint, because then you're using a 2-in-1, interlocking plus weathering. That's my preferred thing, because I want to have a rigid connection there plus the weathering opportunity.
Yeah.
So that's the first thing that comes to mind, but I mean, there's other details that can be explored.
Yeah, I see that as an advantage, because often with in situ construction we specify water bars, but the actual construction can be a problem when it comes to that, because they don't install them properly.
Particularly if it's a straight joint, I agree with you.
Yeah.
If you don't have, as soon as you introduce the interlocking between the two units, you know what I mean?
Yeah.
Then you guarantee, because I mean, very unlikely that moisture, that water can travel, you know what I mean, in this
So you
interlocking
basically
mechanism.
have like a recess that.
You know how we call it, the dog leg.
Yeah.
You know what I mean?
Yeah.
The dog leg with any form of, I don't know, polyurethane type of weather bar, that you're putting it on the inside, and then you always got to have a sealant front and back. You know what I mean?
Yeah,
Regardless.
Yeah. And Daniel,
yeah.
how many reservoirs have you done with your products?
In South Africa, none. I'm still
Okay.
waiting for opportunity, but we've got very nice examples. From the first thing that come to mind is a water retaining structure in Spain, which we've got the details, and the one in Holland. It's even more exciting, because the connections that are used there were stainless steel for this little dam. Yeah.
Yeah, I do see a potential there with reservoirs, especially like, you know, if they're not too high, so it's up to like maybe 3 meters, maybe even higher than that, because there could be a big time saving like with that.
And Don, let me start with the tunneling, because now we've got even more exciting tunneling options for under roads. And I'm really waiting for somebody.
Would you have the capability to do,
people to give us a chance? Hey?
Would you have the capability to do stockpile tunnels? Because, you know, you need quite thick sections for that. You know, maybe up to a meter.
We've got, and we already offering it to the big guys in the market. You know who we're talking about. That we work together, and they are very excited. I've got a white paper written on that, and after this meeting, I'm going to email it to you, because I can't explain it, and it's not the forum here. But I've got a very, very nice stuff and I'm dying to share it with you.
Yeah. No, thank you. Okay.
You're welcome.
Thank you, John.
Okay, any other questions that you'd like to field from the chat, Winston and Vesa?
Let's see if something came up there.
Okay.
How do you deal with the foundations and this?
There's 2 hands up.
Yes. So is there anything, Vesa,
Sorry,
that
I must put mine down. No.
Before we go, no, yeah, yours is down, John. Thank you. Chris and Moilwe, we'll give you an opportunity now. Are there any questions in the chat that you'd like to field before we unmute Chris and Moilwe?
There's one regarding how do you deal with the foundations and design of the foundations to carry the new columns. Actually, we are not doing the foundation designs normally. We are mostly providing connection items and providing some design for the frames if that's required. I don't know if Winston, locally you have done some designs for foundations, but yeah,
yes,
I'm not able to.
If you can just contact us afterwards. We're busy currently in Witbank on the coal mines with precast structures for separator machines, where they basically lift the pH in the coal and the quality of the coal, dividing the good and the bad sections from one another. So on the structure, due to the high health and safety factors the mines have, we were asked to look at the structure, doing it in precast. So we've got precast columns and beams. We're using our hidden PCS connection with our anchor bolts and column shoes. Here we also on the separator structure, because the machine is also at an angle going on top of the structure, which has a feed and a discharge side. So we also had to take dynamic loading on the structure count. On this project, we precast the foundations for the structure as well. It's a very interesting project. so I can share info with you.
Great. Thank you. I've enabled your audio, Chris. Please unmute and ask your question. Good evening. Chris, are you there? Please unmute and ask your question. Okay, let's move on to Moilwe while we're waiting for Chris. I'm going to allow your mic. Please unmute, Moilwe.
Thank you once more again. My question is related to Vesa. So I've seen that the column and beams encourage system connection system. The first question is that are the connecting systems, are they exposed to the environment in terms of corrosion? And the second question is how do you undertake, how do you go on undertaking the maintenance procedure in terms of if ever there's a problem in the connection in a long run, maybe in 10 years later there's a problem with the connections. Does that mean that since like if ever the connection details are hidden within the concrete or the connection itself, how do you go about maintaining the structural integrity in terms of connection from the connection point of view? Do you have to remove the beams or the slabs since like everything was precast? You have to remove everything and maybe fix the problem.
First, I would answer this corrosion protection. So as we spoke during the presentation, that concrete cover usually is the best way to go. So you offset your connection items so that you will have some sufficient concrete cover to the steel parts, and then that would take care of the corrosion as well as the fire. Usually also there's a fire requirement. So sometimes if you have some exposed steel plates, that can cause a problem as well. So that's our recommendation to use it with the concrete cover. So embedded in the concrete, so there is no exposed steels to corrode there. So that would take care of it. For if you have any maintenance needs, that is quite wide question, depends on what kind of maintenance you would require. But maybe I would give you one example. We have done this kind of demountable frames, so where this mechanical connection gives you quite nice freedom that you can even demount those elements. So you can open the connection and you can look inside there. Of course you have to chip away the concrete from the recess and possibly from the joint, depending of what kind of maintenance or checking is required there. But I would say normally this is not required. So you design the structure to be within the lifetime of the building, whether it's 50 or 100 years. Usually the concrete covers, you design according to that. But if there is some need, for example, we have done this kind of demountable connections where we open the connection and then you can still unscrew the threads from the nuts, and then you can check as whatever you want from there in the connection. And then if there is no need to take away those beams or columns from the place, then you just regrout it in. I don't know if I answered your question completely, but it's quite, I would say, a large question. I don't know, maybe you need to specify a little bit more what kind of problem or what kind of maintenance need is there, so we could maybe go through it. But yeah, I hope I answered at least some of the points.
Absolutely, it did answer my question. My question was referring to maintenance in general, so absolutely. Okay. Yeah, perfect that you put grouting in there to cover the steel reinforcement. I mean, like the steel connections, and yeah, that answers my question.
All right, then. Thank you.
Daniel, did you want to add?
Yeah, just to add on. So when we design and we approach you, the question for corrosion obviously is going to come as a dominant factor for you, and we need to advise you or agree with you what's the level of exposure it's required and various, because the level of exposure is or the class of exposure is going to determine what kind of measures need to be put in place to give you the longevity in long term, because we're not designing for this connection to be subjected to maintenance. They're hidden connections. So from the beginning, once we understand the brief, we can advise you accordingly and say, all right, as an entry level, that connection need to be either hot dip galvanized, either a thermal fusion resistant, or any other thing as a first level of precaution. And then we're going to add on the grouting. And then if it's further measurements are required, you can also consider a post-grouting application of any waterproofing compounds. Once the drying it's over, you can perhaps consider using a bitumen coating, and then you've got the 3 lines of defense. You've got the treatment of the product, you've got the grouting itself, or concrete encasing, plus some post completion application. So 1 or 3 line of defense, it will guarantee corrosion-free products. So you don't have to worry about in a long run. If there's any problems, the things can be locally remediated without need to dismantle the whole building and deal with the situation. We never dealt with the situation, but I mean, if we've been tasked to do it, there is a way to deal. But so far in the whole history of the company, we never come across with this time of product failure. So that's all. If you need any more information, please contact Winston or myself, our office. We can expand further for you.
Thank you very much, sir.
Thank you for that. Any final thoughts? I'm just cognizant of time, Winston and Vesa. Any final thoughts before we head on to the conclusion of the session tonight?
Thanks for inviting me. It was interesting for me to join, even I'm far away from Finland, but it's nice to join you guys here in this learning session, and hopefully we provided something useful for you. And then, of course, if you have any questions, you can always contact your local guys there in South Africa, Winston and Daniel.
Thank you so much, Vesa. And from yourself, Winston?
I also just want to say thank you. It was nice presenting this to you, to my colleague Vesa. Thank you for all your preparation from your side on the presentation. I really appreciate it. And yes, back into South Africa, please contact us. There is a lot of different ways to do things, and I do believe with our engagement with you on your projects, with the technology that we offer, that we be of assistance and make a difference in your construction path in the future. Thank you very much.
Thank you so much. And I think in conclusion, from my side, just to say thanks a lot to you, Vesa and Winston, for a very informative discussion indeed. I think I've seen a few comments in the chat just saying the session was very interesting, very engaging, very informative. So thank you for allowing us the opportunity to learn from one another. Just thanks to the entire Peikko team as well, to Daniel, Morag, and the entire team, to SAICE internally as well, the planning team, and to all the attendees tonight. I saw there was quite a variety of locations tonight. I saw someone tuning in from Japan, as far as Japan, and throughout South Africa and various countries as well. We appreciate the time that you've taken out to join us this evening. Just to confirm again, I saw there was a question in the chat to say the session is CPD accredited. Please give us a few days after the session to process the accreditation and to email all of your certificates. And in terms of next steps and events, please keep in touch with us on our social media platforms to see the upcoming webinars and events. There's one happening next week on the 24th of April, which is also CPD accredited. The title for that one is Infrastructure Management through Digital Intelligence. So we'll be having Delta Scan, the CEO of Delta Scan, in that session. We'll share the registration information via bulk mail and social media so that you're able to participate in that. But from our side and from Peikko side, just to say thanks once again. I'm going to play a PowerPoint deck of our programs. If you did not come in early in the session, you can take a quick squiz, but if you are familiar with it, then please feel free to enjoy the rest of your evening, and we'll be in touch again soon. Thank you very much. Good night.
Thank you.
Thank you. Bye-bye.